In the grand cosmic theater, where countless worlds drift in the darkness, our gaze is often drawn to the most mysterious and promising among them. Few celestial bodies have captured our imagination quite like Europa, the enigmatic moon that orbits the giant planet Jupiter. This small, icy world has long been a beacon of hope in our search for life beyond Earth, inspiring generations of scientists and dreamers alike. The tantalizing possibility of a vast, hidden ocean beneath its frozen crust has made Europa a prime target for astrobiology and a symbol of the unknown. It's a place where water, chemistry, and energy might converge, potentially sparking a second genesis in our solar system and offering clues to the origins of life itself. Europa began as just another point of light in the night sky, one of the 4 Galilean moons first observed by Galileo in 1610, its secrets hidden for centuries. But as our technology advanced, data from the Voyager and Galileo missions revealed a world encased in ice, with hints of a dynamic, possibly active interior. The idea of an ocean on another world resonates deeply with our own origins, fueling our curiosity, our hope, and our desire to explore the unknown. Yet, as of January 15, 2026, new scientific findings are challenging Europa's long-held potential for life, forcing us to confront new uncertainties. Recent data cast doubt on the mechanisms that could power a habitable environment beneath the ice, raising new questions about Europa's true nature. We now face a pivotal moment in our exploration, forced to refine our theories and reconsider our expectations for this enigmatic moon, as we continue to seek answers in the vastness of space. To understand Europa's scientific drama, we must first know the moon itself. Europa is the 4th largest of Jupiter's moons, slightly smaller than Earth's moon, and orbits Jupiter every 3.5 days. Its surface is one of the smoothest in the solar system, lacking heavy cratering, and instead covered by a network of dark, reddish-brown lines called lineae. These features suggest tectonic activity, where the icy crust is pulled apart and reshaped by forces from below. Europa's surface is mostly water ice, making it highly reflective, but the reddish streaks are likely salts and sulfur compounds altered by Jupiter's intense radiation. This radiation makes the surface inhospitable, so any potential life would need to be shielded beneath the ice. The thickness of Europa's icy shell is debated, ranging from a few to over 30 kilometers, and understanding it is key to assessing habitability. The ice is both a barrier and a promise, guarding the secrets of the ocean below. Europa's most compelling feature is its hidden global ocean of liquid saltwater beneath the ice. Evidence comes from magnetic field data, which suggest a conductive, salty ocean up to 160 kilometers deep, far deeper than Earth's oceans. This ocean could contain more than twice the volume of all Earth's oceans combined. The excitement isn't just about water. The ocean is likely rich in minerals and salts, hinting at a complex chemistry. On Earth, life needs not just water, but chemical elements and energy sources. Scientists have long hoped that Europa's ocean interacts with its rocky mantle, providing these building blocks. Europa is too far from the sun for solar heating. Instead, tidal flexing from Jupiter's gravity generates internal heat. This tidal heating keeps the ocean liquid, despite the frigid environment. The balance of forces sustaining this ocean has made Europa a top candidate in the search for extraterrestrial life. But the true nature of its seafloor remains a mystery. For years, scientists envisioned Europa's seafloor as geologically active, with hydrothermal vents providing energy for life, but a 2025 study led by Paul Byrne challenges this view, suggesting Europa's seafloor may be geologically dead. The study argues that most internal heat dissipated billions of years ago, and tidal flexing may only keep the ocean liquid, not power volcanism. Instead of a dynamic, fractured seafloor, we may find a cold, rigid, and inactive environment. This would drastically reduce the available energy for life, making a thriving ecosystem unlikely. The hydrothermal vent model was compelling because it mirrored Earth's deep-sea ecosystems. Without active geology, Europa's ocean may be a quiet, sterile abyss. The implications are profound, forcing a major rethink of Europa's habitability. The 20,000 Daum, Rate Sapen Daum, Sutwenfai Naum. Recorded Daum and Daum 15 studies' conclusions are based on detailed modeling of Europa's thermal history. Europa's initial heat from formation and radioactive decay likely dissipated quickly, leaving a cold, solid interior. Tidal heating, while powerful, seems to generate heat mainly in the icy shell, not deep in the rocky core. This is enough to keep the ocean liquid, but not to drive seafloor volcanism. Unlike Io, which is intensely volcanic due to stronger tidal forces, Europa lacks the right conditions for ongoing geological activity. The study challenges previous assumptions, forcing scientists to reconsider what makes a world geologically active and potentially habitable. Europa's geological engine may have stalled, leaving a warm ocean above a cold, dead seafloor. As these new questions arise, NASA's Europa Clipper spacecraft is already en route to Jupiter. Launched in October 2024, Clipper is the largest uncrewed planetary vehicle NASA has built, with massive solar arrays to power its instruments in the dim outer solar system. Its 9 advanced science instruments are designed to investigate Europa's habitability, not to find life directly, but to answer key questions about the ocean, ice shell, and chemistry. The Clipper's ice-penetrating radar will map the shell's thickness, while its magnetometer will measure the ocean's depth and salinity. In light of the new study, Clipper's mission is even more critical. It will test whether Europa's interior is truly quiet or still dynamic. The data it gathers will be crucial for understanding Europa's true potential for life. Whatever it finds, Clipper will redefine our knowledge of ocean worlds. The Europa Clipper's journey is a feat of engineering, taking a complex multi-year trajectory with gravity assist from Mars and Earth. Once at Jupiter in 2030, Clipper won't orbit Europa directly due to intense radiation, but will instead loop around Jupiter, making repeated close flybys. Over 4 years, it will perform 49 flybys, swooping as low as 25 kilometers above Europa's surface. Its instruments will map the surface, analyze the ice's chemistry, and use radar to peer through the shell for subsurface lakes or plumes. If plumes exist, Clipper could sample them directly, offering a glimpse into the ocean's chemistry. Each flyby will provide high-resolution data, transforming our understanding of Europa's geology and habitability. The mission's clever design maximizes scientific return while protecting the spacecraft from radiation. The data from Clipper will settle the debate about Europa's activity and its potential for life. The possibility of a geologically inactive Europa challenges our long-held assumptions about where life might exist in the universe. It forces us to rethink our blueprint for habitability, pushing scientists to consider new possibilities and question established criteria. For decades, we've searched for life by looking for water, chemistry, and energy, focusing on the ingredients that make life possible on Earth. This often means prioritizing worlds with active geology, like volcanic activity or tectonic movement, as prime candidates for life. But what if life can exist in ways we haven't imagined, thriving in environments that seem inhospitable by Earth standards? Even without hydrothermal vents, Europa's surface radiation creates oxidants, potential energy sources that, if mixed into the ocean below, could support life in unexpected ways. The Clipper mission is designed to look for evidence of this crucial ice-ocean interaction, searching for signs that surface chemistry reaches the hidden sea. This prompts a broader re-evaluation in astrobiology, encouraging researchers to expand their thinking and consider a wider range of planetary environments. Perhaps our focus on active geology is too narrow, and we need to be open to alternative pathways for life to emerge. Other ocean worlds, like Enceladus and Titan, each offer unique environments and different sources of energy that could sustain life. These moons challenge us to imagine life that adapts to conditions far removed from our own planet's familiar settings. Understanding Europa's true nature will help us refine our search for life elsewhere, guiding us toward new strategies and questions. Even a negative result is valuable, teaching us about the limits of habitability and helping us avoid repeating past mistakes. These lessons will guide future missions and expand our definition of what it means for a world to be habitable. The Clipper mission's findings will ripple across planetary science, inspiring new ideas and reshaping our understanding of life's potential. Ultimately, these discoveries will shape the next generation of exploration, opening doors to worlds we once overlooked. To truly find life in the cosmos, we may need to look beyond Earth-like models and embrace the unknown possibilities that await us. As of January 15, 2026, Europa stands at a crossroads, still promising, but now shrouded in uncertainty. The hopes of finding a vibrant, active world beneath its icy shell have been tempered by new data, yet the allure of this distant moon remains as strong as ever. The vision of a volcanic sea floor teeming with energy is now challenged, but this is science at its best, constantly evolving, adapting to new evidence, and refining our understanding of the cosmos. Each discovery, even those that complicate the story, brings us closer to the truth. The Europa Clipper, on its journey across millions of miles, embodies our relentless drive to resolve these mysteries with hard data and direct exploration. It is a testament to human curiosity and ingenuity. Whether it finds a dynamic, active world or a quiet, frozen one, the mission will be a monumental success, providing our first detailed look at an ocean world beyond Earth. Every image and measurement will deepen our understanding. This new chapter pushes us to be more creative in our search for life, considering alternative energy sources and new pathways for biology to emerge. It challenges us to think beyond what we know from Earth. The universe may not offer convenient, Earth-like analogs. Life elsewhere could be stranger than we imagine, thriving in environments we once thought impossible. Europa's silence is not the end, but an invitation to broaden our thinking about life's possibilities. It reminds us that the search for life is as much about expanding our imagination as it is about gathering data. Our quest to understand Europa is part of humanity's enduring desire to find our place in the cosmos, to connect with something greater than ourselves, and to answer the age-old question, are we alone? The coming years, as Clipper arrives and begins its work, promise thrilling discoveries and perhaps even paradigm-shifting surprises. Whatever Europa reveals, it will reshape our view of the solar system and forever change our search for life beyond Earth. Imagine a world smaller than our moon, wrapped in a shell of ice. This is Europa, orbiting Jupiter in a cosmic dance. Beneath its frozen surface lies more liquid water than all of Earth's oceans combined. That hidden ocean makes Europa one of the most intriguing places in our solar system. It's a place where we might finally answer, are we alone? From afar, Europa looks still, a smooth white sphere streaked with reddish-brown lines, like a cracked eggshell. But that stillness is an illusion. Europa is dynamic, its surface constantly shifting under Jupiter's immense gravity. This gravitational tug-of-war generates heat, keeping the ocean beneath from freezing solid. That hidden warmth could be the key to life. We are explorers by nature, always wondering what's out there. Our robotic spacecraft have flown past Jupiter and its moons, sending back images and data that transformed our understanding of Europa. They revealed a world far more complex than we ever imagined. The story of Europa is a cosmic detective story. The clues, cracks, plumes of water vapor, a strange magnetic field, point to that vast, dark ocean. And where there is water, there is the possibility of life. This isn't just science fiction, it's a real scientific possibility. The journey to understand Europa is a journey to understand our own place in the cosmos. Each discovery brings us closer to answering the ultimate question. Europa beckons us to look closer, to keep searching. Its secrets could change everything we know about life in the universe. The adventure is just beginning. What will we find beneath the ice? The answer could redefine our understanding of life itself. Europa's story is our story, a story of curiosity, discovery, and hope. Europa isn't the biggest or most active moon, but it's unique. Its surface is one of the smoothest in the solar system. Few mountains, few craters. This suggests the surface is young and constantly renewed, like a frozen lake resurfacing itself. Temperatures plunge to minus 160 degrees Celsius, and Jupiter's radiation makes the surface deadly, but the ice acts as a shield, protecting whatever lies beneath. The thickness of this ice is still a mystery, maybe a few kilometers, maybe tens. Below is the prize. A global ocean of liquid water. The evidence is overwhelming. Europa is like a planet-sized bottle of water sealed in ice. This ocean is vast, dark, and under immense pressure, but it could be teeming with possibilities. Europa's orbit is slightly elliptical, so Jupiter's gravity flexes the moon, creating friction and heat. This process, called tidal heating, keeps the ocean from freezing solid. It's the same force that causes tides on Earth, but on a much grander scale. Tidal heating is the engine that powers Europa's hidden world. The constant renewal of the surface hints at activity below. Europa's icy shell and hidden ocean make it a world unlike any other. It's a place where the impossible might just be possible. That's why Europa stands out as the icy enigma of our solar system. How do we know there's an ocean on Europa? We look for clues from afar. NASA's Galileo spacecraft detected a changing magnetic field, hinting at a salty, liquid ocean beneath the ice. The surface is covered in long cracks and ridges, resembling sea ice on Earth, evidence of a floating ice shell. Chaotic terrain suggests the crust has broken and refrozen, likely floating atop liquid water. The Hubble Space Telescope has spotted plumes of water vapor erupting from Europa's surface, possible geysers from the hidden ocean. If confirmed, we could sample Europa's ocean by flying through these plumes, no drilling required. The reddish-brown material in Europa's cracks may be salts and minerals from the ocean, altered by radiation. Studying this material could reveal the ocean's chemistry and its potential for life. Each clue, magnetic fields, cracks, plumes, and mysterious minerals, strengthens the case for a vast, subsurface sea. Europa's surface is a window into its hidden depths. The evidence is mounting. Beneath the ice, a world of water awaits. The next step is to get closer and find out what's really there. The search for life begins with these tantalizing signs. Life needs three things: liquid water, energy, and the right chemicals. Europa has water in abundance, but what about energy? On Earth, most life relies on sunlight, but Europa's ocean is in total darkness. Tidal forces could create hydrothermal vents on Europa's seafloor, just like those in Earth's deep oceans. These vents spew hot, mineral-rich water, supporting entire ecosystems without sunlight. If Europa has similar vents, they could power a hidden ecosystem. The third ingredient is chemistry: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Europa likely has these elements, delivered by its rocky seafloor and cosmic impacts. The stage is set: water, energy, and chemistry, mixing for billions of years. Could simple molecules have evolved into life? The possibility is real, and that's why Europa is so compelling. If life can start here, it could start anywhere. The search for life on Europa is the search for life's universal recipe. The answers may be waiting in the darkness beneath the ice. Tidal heating is the force that makes Europa special. Jupiter's immense gravity stretches and squeezes Europa as it orbits, generating friction and heat inside the moon. This internal heat keeps the subsurface ocean liquid despite the cold of space. The balance is delicate. Too much heat, the ocean boils; too little, it freezes. On Europa, conditions seem just right. Tidal energy may also make the seafloor geologically active, driving volcanism and creating hydrothermal vents. These vents could provide chemical gradients and nutrients, essential for life. Jupiter acts as a life support system, powering Europa's potential habitat. It's a reminder that life doesn't always need a star. Sometimes, a planet's gravity is enough. This expands our idea of where life might exist. The search for habitable worlds must look beyond the obvious. Europa teaches us to think outside the box. The engine beneath the ice could be the spark for life. The possibilities are as vast as the ocean itself. Tidal heating is the heartbeat of Europa's hidden world. To imagine life on Europa, we look to Earth's deep oceans. In 1977, scientists discovered hydrothermal vents, black smokers on the seafloor, teeming with life in total darkness. These ecosystems thrive on chemosynthesis, not sunlight. Microbes use chemicals like hydrogen sulfide for energy, forming the base of a unique food chain. Larger creatures, tube worms, crabs, ghostly fish, depend on these microbes. This discovery proved life can exist without sunlight, in extreme conditions. Europa's predicted environment, rocky sea floor, hydrothermal vents, liquid water, mirrors these deep-sea communities. Studying Earth's vents prepares us to search for life on Europa. The dark depths of our oceans may hold the key to finding life in Europa's ocean. The parallels are powerful and inspiring. How do we explore Europa's hidden ocean? With robots, NASA's Europa Clipper will perform dozens of close flybys equipped with radar, cameras, and spectrometers. It will measure ice thickness, map the surface, and sample any water plumes for organic molecules. The European Space Agency's JUICE mission will also study Europa, complementing Clipper's findings. These missions are the reconnaissance phase, scouting the territory and gathering crucial data. The next step, a lander to analyze the ice up close, searching for biosignatures. It could deploy a seismometer to listen for the ocean's tides and currents. These robotic explorers will pave the way for the ultimate challenge, reaching the ocean itself. Each mission brings us closer to answering the question of life beyond Earth. The future of exploration is robotic, and it's already on its way. The ultimate goal is to reach Europa's ocean. The ice shell could be over 20 kilometers thick, an immense engineering challenge. Scientists envision a cryobot, a robot that melts through the ice, powered by a nuclear reactor. As it descends, it would unspool a cable to communicate with the surface. Once through, it would release a hydrobot, a miniature submarine, to explore the ocean. The hydrobot would search for hydrothermal vents and signs of life. Imagine the first images from Europa's ocean, an alien world revealed. Even finding simple microbes would be a discovery that changes everything. It would prove life is not unique to Earth, but a cosmic phenomenon. The challenge is immense, but the reward could be the greatest in human history. Why explore Europa? Because the search for life is the search for ourselves. All life we know shares a common origin, on Earth. But what if life began independently on Europa? That would be a second genesis. It would mean life is not a rare fluke, but a common outcome in the universe. The discovery would ignite a new scientific revolution, astrobiology in practice. We could study alien biochemistry, genetics, and energy systems. It would transform our understanding of life itself. Europa, a tiny point of light near Jupiter, represents our drive to explore and understand. The journey will be long and difficult, but it's a journey we must take. In the dark depths of Europa's ocean may lie the answer to humanity's oldest question. Are we alone? The search continues, across the ice, into the unknown. Orbiting the giant planet Jupiter, Europa is a small, enigmatic moon that has captured the imagination of scientists, astronomers, and dreamers alike for generations. Suspended in the cold, dark reaches of our solar system, Europa stands out as one of the most intriguing worlds we know. For decades, researchers have been drawn to Europa's mysteries, wondering what secrets might lie beneath its icy shell. The moon's allure isn't just scientific, its potential to answer some of humanity's oldest questions makes it a beacon for exploration. This world, with its smooth, bright surface crisscrossed by dark lines and ridges, is more than just another moon orbiting a distant planet. Its appearance hints at powerful forces at work beneath the ice, shaping and renewing the landscape in ways we are only beginning to understand. Europa is widely considered one of the most promising places in our solar system to search for life beyond Earth. Its unique environment has inspired countless artists, writers, and scientists to imagine what might exist in its hidden depths. Beneath its thick, frozen crust, compelling evidence suggests the presence of a vast, global ocean of liquid, salt water, possibly containing twice as much water as all of Earth's oceans combined. This ocean is kept from freezing solid by the gravitational forces of Jupiter, which generate heat through tidal flexing. The presence of liquid water, along with the right chemical ingredients, makes Europa a prime candidate for astrobiology. If life can exist in the extreme environments of Earth's deep oceans, could it also thrive in Europa's hidden sea? Our journey to understand Europa began over 4 centuries ago, when Galileo Galilei first observed it through his telescope in 1610. But it wasn't until the Voyager spacecraft flew past in the late 1970s that we truly glimpsed its unique, dynamic surface and realized how different it was from other moons. Unlike our cratered moon, Europa's surface is remarkably young and constantly renewed, with few impact scars. This suggests that active processes, perhaps driven by the ocean below, are continually reshaping its icy exterior. The story of Europa is about potential, about the tantalizing possibility that life could exist elsewhere in our solar system, and about the drive to explore the unknown. Its subsurface ocean, warmed by Jupiter's immense gravitational pull, could provide the energy and chemistry needed for life to emerge and survive, even in the absence of sunlight. Exploring Europa isn't just about searching for aliens, it's about understanding the origins of life itself, and whether the conditions that sparked life on Earth might be found elsewhere. Are we alone in the universe, or is life a common thread, woven throughout the cosmos, waiting to be discovered in unexpected places? Europa offers a natural laboratory to test these profound questions, right in our cosmic backyard, just a short journey away in astronomical terms. Unlocking its secrets could connect the hidden ocean of Europa to the very first microbes on Earth, and perhaps to the story of life throughout the universe. Europa's surface is a forbidding landscape of solid ice, stretching as far as the eye can see. This frozen expanse is both beautiful and mysterious, with its pale glistening plains reflecting the distant sunlight. Scientists estimate that the ice shell may be anywhere from 15 to 25 kilometers thick, an immense barrier separating the surface from what lies beneath. This icy shell acts as a powerful insulator, trapping heat and protecting the subsurface ocean from the frigid vacuum of space. Without this protective layer, any water below would quickly freeze solid. The ice also serves as a shield against Jupiter's intense radiation, which bombards the surface relentlessly. Beneath the ice, the ocean is safe from these harmful rays. Deep below, any potential ecosystem would be protected from both the cold and radiation, creating a stable environment where life could possibly take hold and evolve over time. The surface is covered in a web of cracks and ridges, evidence of powerful tidal forces from Jupiter stretching and squeezing the moon. These features hint at a restless world beneath the ice. These tidal forces generate heat deep within Europa, keeping the ocean liquid and causing the ice to crack, shift, and even move over time, much like glaciers on Earth. Some cracks may act as pathways, allowing material from the ocean to reach the surface, and possibly letting surface chemicals seep down into the ocean below. The so-called chaos terrain, jumbled regions of broken ice, suggests recent and ongoing interactions between the ocean and the surface, as if the moon is constantly reshaping itself. The reddish-brown streaks that crisscross Europa's surface may be salts or other compounds brought up from the ocean, offering tantalizing clues about its hidden chemistry. These chemical fingerprints are waiting to be studied by future missions, which could analyze the surface and unlock secrets about the ocean's composition and its potential for life. Europa's ice is not just a barrier, it's a window into the moon's hidden ocean, holding the promise of discovery and perhaps even the first evidence of life beyond Earth. The strongest evidence for Europa's vast hidden subsurface ocean comes from the Galileo spacecraft, which spent years exploring the Jupiter system and sending back invaluable data. Galileo detected a mysterious magnetic disturbance near Europa, one that scientists now believe is best explained by a global layer of salty, electrically conductive water beneath the moon's icy crust. This ocean remains liquid not because of sunlight, but due to tidal heating, an immense force generated by Jupiter's powerful gravity, which flexes Europa's interior and keeps its ocean from freezing solid. Imagine a world of utter darkness, where sunlight never reaches, yet life could still thrive around hydrothermal vents on the ocean floor, just as it does in the deepest parts of Earth's own seas. These vents could provide not only water, but also a steady supply of nutrients and energy, everything that's needed to support living organisms, even in the absence of light. In this alien ocean, Europa may harbor a cradle for life, completely independent of sunlight, relying instead on chemical energy and heat from the moon's interior. The possibility of a self-contained biosphere, thriving in the dark for billions of years, is one of science's most thrilling and profound prospects, suggesting that life can adapt to environments we once thought impossible. If life can exist here, in Europa's hidden ocean, it could exist on countless other worlds across the galaxy, moons and planets with similar conditions, waiting to be discovered. Life, it seems, might not need sunlight at all, just water, the right chemistry, and a source of heat to spark the incredible diversity we see on Earth. Europa challenges our deepest assumptions about where and how life can arise, pushing the boundaries of our imagination and scientific understanding. Its hidden ocean could be the key to unlocking the secrets of life's true potential, both on our planet and beyond. The search for life on Europa is more than a quest for discovery. It's a search for life's universality, and for our place in the cosmos. Our search for life beyond Earth is, at its core, a search for water. Wherever we find liquid water on Earth, we find life. Even in the most extreme environments, water's unique properties make it the perfect medium for life's chemistry. On Europa, the ice shelf floats atop a vast ocean. Just as ice, floats on Earth's lakes. Life on Earth likely began in water, perhaps around deep-sea hydrothermal vents. The discovery of Europa's ocean was a watershed moment, presenting a world with the critical ingredient for life in abundance. Unlike Mars, which may have had water in the past, Europa likely has it now. This makes Europa a compelling target, not just for fossils, but for living ecosystems. The quest to understand Europa is a quest to see if life's story has a sequel elsewhere. In searching Europa, we're searching for a new chapter in the story of life. Studying Europa is like peering back in time at early Earth. Life on our planet began in the oceans, shielded from harsh conditions above. Europa's subsurface ocean, protected by ice, mirrors this environment. The ocean is likely salty and in contact with a rocky seafloor, providing minerals and nutrients essential for life. Tidal heating could drive hydrothermal vents, offering energy for chemosynthetic life, just as on early Earth. Europa may represent a planetary time capsule, preserving conditions that gave rise to life here. Exploring Europa tests our theories about life's origins. If life arose independently there, it suggests biology is a natural outcome of planetary evolution. Europa could show us that life is not a fluke, but one kami kan sabran and krodan tiar, bodo de spore bo combat, a cosmic inevitability. The Galileo spacecraft revolutionized our understanding of Europa. Its magnetometer detected an induced magnetic field, pointing to a global ocean of salty water. Galileo's images revealed chaos terrains and long cracks, showing a dynamic, renewing surface. The lack of impact craters means Europa's surface is young and active. These discoveries made Europa a primary target for future exploration. Galileo's mission ended in 2003, but its legacy endures. Every new mission builds on Galileo's foundation. It was the robotic pioneer that first revealed Europa's watery secrets. After Galileo, the Hubble Space Telescope detected plumes of water vapor erupting from Europa's surface. If these plumes originate from the subsurface ocean, they offer a way to sample Europa's hidden sea without drilling. A spacecraft could fly through a plume and analyze its chemistry directly. This could reveal the ocean's salinity, organic molecules, and even potential biosignatures. The plumes suggest Europa is geologically active, with pathways connecting the ocean to the surface. Their existence has shaped the design of future missions, like Europa Clipper. Sampling a plume could bring us closer than ever to discovering alien life. Europa's plumes are a tantalizing shortcut to its deepest secrets. The possibility of life on Europa raises the question of panspermia. Could life travel between worlds? Early in the solar system's history, impacts could have blasted life-bearing rocks from Earth to Europa. If life exists there, it might be a distant cousin, sharing a common origin with us. Alternatively, if Europan life is truly alien, it would prove life can arise independently. Either scenario would transform our understanding of biology and our place in the universe. Life on Europa could mean life is resilient and widespread. The discovery would show that biology is a fundamental property of the cosmos. Whether cousin or alien, Europan life would forever change our perspective. Exploring Europa is a deeply human quest, reflecting our curiosity and desire to understand our place in the cosmos. In searching for life there, we learn more about life here, its origins, resilience, and requirements. Europa is a natural experiment, showing what happens on a water world without continents or sunlight. Finding life on Europa would be a turning point, transforming our view of the universe from empty to vibrant. The discovery would ripple through science, philosophy, and culture. Exploring Europa inspires innovation and unites us in a common goal. The secrets beneath its ice may hold the key to our past and shape our future. Far from the warmth and light of the sun, in the cold outer reaches of our solar system, locked in Jupiter's immense gravitational grip, orbits Europa, a small, enigmatic world that has fascinated astronomers for decades. At first glance, Europa appears to be a smooth, frozen sphere, its surface etched with dark, reddish-brown cracks and mysterious streaks that crisscross the ice. But beneath this icy shell lies one of the solar system's greatest secrets, a vast, hidden ocean, stretching for thousands of kilometers beneath the frozen crust. This ocean, sealed under kilometers of solid ice, could harbor the conditions for life as we know it, or perhaps life as we've never imagined. Europa is constantly flexed and squeezed by Jupiter's powerful gravity and the gravitational pull of its neighboring Galilean moons, generating internal heat deep within. This tidal heating keeps the subsurface ocean liquid, even though surface temperatures plunge to a frigid -160 degrees Celsius, cold enough to freeze almost anything solid. The fractured, chaotic surface hints at a dynamic world below, where liquid water churns in perpetual darkness, reshaping the ice above. On Earth, life thrives around hydrothermal vents deep in our oceans, feeding on chemical energy rather than sunlight, proving that life can exist in the most extreme environments. Could similar vents exist on Europa's ocean floor, powered by tidal forces and internal heat, providing energy for alien ecosystems? The Galileo spacecraft gave us our first tantalizing clues, detecting magnetic disturbances that suggest a global saltwater ocean, rich in minerals, and possibly energy sources. Hubble has even spotted plumes of water vapor erupting from Europa's surface, cosmic geysers that may carry samples from the hidden ocean into space, offering a glimpse into its mysterious depths. These plumes offer a tantalizing opportunity for future missions, to study Europa's ocean without drilling through its thick, icy shell, by simply flying through and sampling the material. Europa is more than just a frozen moon. It's a world with the potential for life, a place where the boundaries of our imagination and science are constantly being tested, waiting to be explored. The search for answers has only just begun, as new missions prepare to unlock Europa's secrets and reveal what lies beneath its icy surface. What secrets lie beneath Europa's icy crust? Could this distant icy jewel be home to life beyond Earth? The next chapter in our search for life in the cosmos may begin here. Water is the universal solvent for life. It's the one ingredient that every living thing on Earth depends on, from the simplest microbe to the most complex animal. Without water, life as we know it simply cannot exist. Wherever we find liquid water on Earth, we find life, no matter how extreme the environment. From boiling hot springs to the icy darkness beneath Antarctic glaciers, life finds a way to thrive wherever water is present. This simple truth drives our search for life beyond our planet. Follow the water. It's a guiding principle for astrobiologists, shaping every mission and every question we ask about the cosmos. Mars may have underground water, and Saturn's Enceladus has plumes, but Europa stands apart. Its mysteries are deeper, its potential even greater. Its ocean is not a mere puddle. It may contain more water than all of Earth's oceans combined. Imagine an entire world hidden beneath a shell of ice with a vast global sea. Imagine a small moon, yet a true water world. Europa's ocean could stretch for hundreds of kilometers in depth, dwarfing anything on our own planet. The scale is staggering, transforming Europa into a prime candidate for life. It's a place where the conditions for biology might be just right. Evidence suggests Europa's ocean is salty, like Earth's, and in contact with a rocky seafloor. This connection is crucial, as it allows for chemical reactions that could support life. This interaction creates a chemical cauldron, ideal for complex molecules and potentially life. Hydrothermal vents on Earth teem with organisms fueled by energy from the planet's interior. Hydrothermal vents could provide energy, just as they do on Earth. These environments are some of the most promising places to look for life beyond our world. Europa offers the holy trinity for life: water, energy, and chemistry. All the essential ingredients are present, waiting to be explored. These are the same conditions that allowed life to emerge on Earth. Our own origins may be mirrored in the depths of Europa's ocean. To find them all on Europa is extraordinary. It's a cosmic invitation to search for life in a place far from home. It's why scientists are so captivated by this distant moon. The possibility of discovery drives new missions and inspires generations. Europa is not just a curiosity, it's a potential cradle for life. It could answer one of humanity's oldest questions: are we alone? The search for life there is more urgent than ever. Each new discovery brings us closer to understanding our place in the universe. What might we discover in its hidden depths? The answers could change everything we know about life itself. For millennia, we've gazed at the stars and wondered, are we alone? Today, we have the technology to seek answers, sending probes to distant worlds, searching for signs of life. Discovering even simple microbes elsewhere would be a revolution, proving life is not unique to Earth. It would mean life is a natural outcome of the universe, not a miraculous fluke. We'd become part of a cosmic continuum, not the sole proprietors of life. This quest is driven by our innate curiosity, the same spirit that sent explorers across oceans. Missions like Europa Clipper are our modern ships of discovery, carrying humanity's hopes into the unknown. The search for life on Europa unites scientists and engineers worldwide. It's a grand challenge, pushing the boundaries of technology and imagination. The answer to, are we alone, may be waiting beneath Europa's ice. If life exists in Europa's ocean, what might it be like? The possibilities are as vast and mysterious as the ocean itself, hidden beneath miles of unbroken ice. Europa's dark waters could be home to forms of life unlike anything we've ever seen. Most likely we'd find microbes, single-celled organisms thriving in darkness, feeding on chemical energy. These tiny pioneers could be the first inhabitants of an alien world, surviving where sunlight never reaches. These chemotrophs could cluster around hydrothermal vents, just as they do on Earth's ocean floor. Here, life would draw energy from the planet itself, not from the sun. In this alien sea, vents would be oases, supporting entire ecosystems. Around these warm, mineral-rich springs, life could flourish in unexpected abundance. Simple multicellular life might evolve, grazing on microbial mats, perhaps even more complex creatures, adapted to the dark and cold. Over time, evolution could give rise to unique forms, each perfectly suited to Europa's extreme environment. Without light, sight would be useless. Life might sense its world through sound, chemicals, or electric fields. Creatures could communicate with vibrations, or navigate by detecting subtle changes in their surroundings. Europa's life could be gelatinous, armored, or utterly alien, built from unfamiliar molecules. Their bodies might glow, shimmer, or be armored against the crushing pressure. We must be ready for surprises. Life there may not even use DNA. It could be based on a chemistry we've never encountered, challenging everything we know about biology. The discovery of a single microbe would revolutionize biology, giving us a second genesis of life. It would prove that life is not unique to Earth, but a cosmic phenomenon. It would launch a new science, comparative biology on a cosmic scale. Scientists everywhere would race to understand how life began, and how it survives in such alien conditions. We're not just searching for ourselves, we're searching for the unknown. Each discovery would expand our sense of what's possible in the universe. What will Europa teach us about life's possibilities? The answers may change our understanding of life forever. Imagine the day. A signal from Europa arrives, carrying world-changing news. A spacecraft has sampled a water plume, tasting Europa's ocean. Scientists watch as data reveals complex organic molecules, unmistakably biological. Every possibility is checked, every alternative ruled out. When confirmed, the announcement is calm but electrifying. We are not alone. Those words echo worldwide, translated into every language. For the first time, we have evidence of life beyond Earth. Even a simple microbe in a distant ocean would be the greatest discovery in science. Europa would become a household name, its icy surface iconic. We'd look at Jupiter with new eyes, knowing one of its moons harbors life. The discovery would unite humanity, if only for a moment. Our divisions would seem small compared to this cosmic revelation. We'd all be Earthlings together, in a universe suddenly less lonely. The search for life would enter a new era. What else awaits us in the cosmos? Finding life on Europa would trigger a new Copernican revolution. Just as Copernicus showed Earth isn't the center of the universe, this discovery would show life isn't unique to Earth. We'd see ourselves as one expression of a universal phenomenon. The impact would ripple through science, philosophy, and religion. Our place in the cosmos would be forever changed, humbling yet empowering. We'd become custodians of life, responsible for protecting our own biosphere. The knowledge that life can arise elsewhere would make Earth's life seem even more precious. Our collective identity would shift, fostering humility and unity. The universe would become a cosmic garden, filled with possibility. We'd be citizens of a living cosmos, our future shaped by this new perspective. What new questions would we ask, knowing we're not alone? The discovery would ignite a new era of exploration and innovation. The next step: send robotic explorers to study Europa's life in its native ocean. This challenge would drive advances in robotics, AI, materials and power systems. Nations would collaborate, pooling resource and expertise. Technologies developed for Europa would benefit life on Earth: clean energy, advanced robotics, new medical tools. The quest would inspire a new generation of scientists and explorers. School children would dream of alien oceans and distant worlds. STEM fields would flourish, fueled by wonder and ambition. The Europa generation would be defined by curiosity and ingenuity. Our journey of discovery would continue, shaping our future for generations. What will we achieve inspired by life on Europa? Knowing life exists on Europa would transform our cosmic perspective. With two life-bearing worlds in one solar system, the odds of life elsewhere would soar. The Drake equation's uncertainties would shrink. Life would seem a cosmic imperative. The search for life on exoplanets would intensify, guided by new confidence. Icy worlds once dismissed as barren would become prime targets. SETI and other projects would gain new urgency. If simple life is common, intelligence may be too. The dream of contact would move from fiction to plausible goal. We'd see the solar system as a neighborhood rich with potential. Human missions to Mars and beyond would gain new purpose. We'd become citizens of the solar system, destined to explore and understand our cosmic home. The discovery of life on Europa would mark a turning point for humanity. It would unite us in a shared quest, a grand narrative for our species. Global cooperation would accelerate space exploration and inspire solutions to Earth's challenges. Knowing life isn't unique to Earth would reinforce our drive to become a multiplanetary species. We might see ourselves as custodians of life, carrying its spark to other worlds. Our future would be written among the stars, not just on Earth. The discovery would fill us with wonder, hope, and a sense of purpose. We are the universe made conscious, embarking on a journey of discovery. The cosmos awaits, and for the first time, we know we are not alone. What new adventures will we find in the starlit future?